Circles in the coordinate plane. Our objectives are to write equations and graph circles in the coordinate plane, as well as use the equation and graph of a circle to solve problems. Who uses this? Meteorologists use circles and coordinates to plan the location of weather stations. The equation of a circle is based on the distance formula and the fact that all points on a circle are equidistant from the center. Basically, the radius of a circle doesn't change as long as you're still looking at the same circle or a circle that's congruent to it. Well, our distance formula equals the square root of the quantity x2 minus x1 squared plus the quantity y2 minus y1 squared. Let's just be a little bit more specific. So we're going to make the center of our circle HK. And the point on the circle will stay as xy. So if we substitute xy and hk into our distance formula, we have the square root of the quantity x minus h squared plus the quantity y minus k squared. Well, to get rid of this square root symbol, we're going to simply square both sides of the equation, giving us r squared equals the quantity x minus h squared plus y minus k squared. And folks, that would be the equation of a circle. Let's try writing the equation of a circle. Write the equation of each circle. Let's start with the first one together. Circle A with center A is at 4, -2 and has a radius of 3. Well, our formula is x minus h squared plus the quantity y minus k squared equals our radius squared. And now we can simply substitute our information in. So we have x minus 4 squared plus y minus our k, which is -2 squared, equals 3 squared. Well, let's just simplify this up a little bit. We have x minus 4 squared plus y, and it's minus a negative, so it's like the same thing as adding a positive, squared equals 3 squared, which is 9. And that is the equation of circle A. Let's try doing the equation of circle B. Now in this case, they didn't give us our radius, but we can use the distance formula to solve and find it. So our radius is going to equal the square root of -2 minus -6 squared plus 6 minus 3 squared. And when we take -2 plus 6 and square it, then add 6 minus 3 and square that, we end up with the square root of 25, which equals 5. So our radius is 5. Now we can plug our information in. Keep in mind, our point B is the center of our circle, so that is our HK. So we have x minus -6 squared plus y minus 3 squared equals 5 squared. And when we simplify, we have x plus 6 squared plus y minus 3 squared equals 25. And that would be the equation for circle B. Let's try graphing them now. We have to think a little bit backwards on this. So let's start with looking at the radius. Well, we know our equation equals the radius squared. So take the square root of 25, which is 5, and there's our radius. Now the center of our circle would be our h and k. Well, I don't see any h and k here. So, as a suggestion, what's something that you can add or subtract to anything and it's not going to change? Any value. Well, 0. So the circle is centered at the origin. Having a few extra points, other than just your center and your radius, will help you graph a much more accurate circle. So take a moment and try plugging -5, -4, -3, 3, 4, 5, and 0 in for x and see what you get as an output for y. Now that you've had a moment to do that, let's see if you came close to what you should have had. So y should have been 0, -4 should have been plus or minus 3, -3 should have been plus or minus 4, 0 should have been plus or minus 5, 3 should have been plus or minus 4, 4 should have been plus or minus 3, and 5 should have been 0. Then you can just plot each of these coordinates. Don't forget to plot your center. And when you do so, you have a circle. And it is centered at 0. Let's try one more example. Your radius must be what? Well, let's look at our equation. You know that it equals our radius squared. So therefore, our radius must be 3. And our center is going to deal with our h and k. Now remember, our formula had a minus in it. And whatever we did, we minus a negative, it became a positive. So this is really minus -1. So our h is really -1. And we're subtracting 2. So keep it 2. My suggestion is think opposite. So if it says +1, write -1. If it says -2, write +2. So thinking opposites kind of helps. Alright, so if we plot our -1, 2, and then we go a radius of 3, we will have ourselves a nice circle. Now my suggestion is when you go to do these, start with your center and then go 1, 2, 3 and plot that point. And then 1, 2, 3, plot that one. 1, 2, 3, plot this one. And do the same here. And then you've got a decent amount to be able to at least make a relatively close circle. It's nice to have a couple extra points though to ensure that you've really got a circle going on. Let's try a meteorology application. Meteorologists are planning the location of a new weather station to cover Osceola, Waco, and Ireland, Texas. To optimize radar coverage, the station must be equidistant from the 3 cities which are located on a coordinate plane. So at A we've got 2, 5, B we've got 3, -2, and C we've got -5, -2. What are the coordinates where the station should be built? So we want to find where our circle is going to be, and then find the center point of that circle. So we can find the midpoint of Ireland and Waco, and then go perpendicular to that one, and do the same thing between points A and C. And when we do so, we have an intersection, and we'll call that intersection P. Once we do that, we have 3 of the points of our circle, so you can simply find the distance formula, or use the distance formula to find the radius of your circle. And once you find the radius of your circle, you can continue that in different directions to actually formulate your circular area. Well, that concludes our lesson on circles in the coordinate plane.